All right, good afternoon, everyone. Welcome to a 2 p.m. math lesson, Sec 4 E-Math to be exact, on a wonderful day with Teacher Jason over here. All right, so hopefully I'll be able to give you a proper lesson for today as such. Now, again, some general rules. Just make sure that be patient and understanding as I go through the concept because we are all in this together. Gracious and respectful behavior even in digital space. So just make sure whatever you type, just make sure it's of a certain good tone. Lastly, ask good and relevant questions with regards to today's lesson. Okay, so what are we learning today? So this is a particular lesson whereby you're actually going to zoom into a particular statistical tool to how we identify statistics. So you're going to see yourself the notion of what is the meaning of cumulative frequency. And after that, how are we going to apply it to the notion of percentiles and these measures over here? We call them the measures of spread. How do we actually sort of apply there accordingly? Now, before we actually do that, let's recap something. Okay, I hope you find this familiar because it's actually what we call a frequency table, whereby this frequency table is read as such. So example, what does this frequency mean according to the height of the plants here? It is just saying, oh, okay, for height of the plants between less than 30, no, more than 30, but less than or equals to 35, there will be 5 of them. So essentially, this represents in this context the number of plants at the specified range that I've just highlighted to you in green. And then what happens is you actually can do it for the rest. So in this case, 35 to 40, the height of the plant is going to be, there are only 10 of them. 40 to 45, there's going to be 8 of them. 45 to 50, there's only going to be 7 of them. Right? So that's how we read it. Now, what is the notion of cumulative frequency? If you understand the notion, cumulative, basically we are accumulating the frequency as it goes by. So what we are doing here is we are actually sort of, you can think about it, adding up. So if I want to know the cumulative frequency, or in this case, the cumulative frequency of X, okay, what is the notion of X over here? What do we represent as the cumulative frequency of X? We are actually talking about less than or equals to X. So what we do over here is the notion of adding up. So we actually add up the frequencies that are less than or equals to X. Okay, and take note over here, when we actually do the add up, the last cumulative frequency over here is always the total frequency. Now, why is this the case? Okay, why is it the case? Why is this always the case? Okay, so over here, what we do, we will do a work example to actually sort of ease yourself, or maybe a bubble question coming up soon, to ease ourselves to understand what cumulative frequency is. So if you look at this particular work example over here, all right, this frequency table shows the height of 30 plants. So we are looking at this frequency table and how we are actually easing into cumulative frequency over here. All right, so let's take a look. If you look at the difference between these two over here, all right, the height of the plants, okay, the frequency is written as such. Okay, it's always a certain range. Okay, in this case, two-sided. There's a lower bound, there's an upper bound. But for the height of the plants for a cumulative frequency, it's going to be only one-sided. So we are looking at just one side. Okay, so that's one difference. You can take note, one side for cumulative frequency. Now, looking at this table over here, what am I trying to say? How do we actually fill up the cumulative frequency? Essentially doing the same thing as filling up the values. So let's take a look at how we identify these values over here. Now, A, what does the value A represent? A, in this case, represent the plants that are just less than or equals to 35. How does that correspond to the table at the left? How does it correspond to the table at the left? Well, if you were to realize, less than 35 just corresponds to 30 to 35. That's the only one. So therefore, in this case, it will correspond to this one over here. And therefore, for the first one, A is just 5. Okay, first one, quite straightforward. The first one, usually they are equal to each other. Now, for the second one, B. When I'm looking at 35 to 40, Okay, 35 to 40. Okay, sorry for that. 35 to 40. And in this case, I'm zooming into 40 over here. Okay, let's think about it. To fill in the number for x less than or equals to 40, suppose if I were to call this, since I'm color coding it, suppose if I were to call this column row y and this one is row g, which frequencies do I consider? Is it y, g, or both y and g? Write your answers down, think about it. Is it just y, g, or both y and g for this frequency here? I'll let you guys think a little about it. Less than or equals to 30. All right, Denise, that's actually correct. Yeah, Chloe, that's actually correct as well. Perfect. All right, Denise, you've given me the answer. That means you understand. Very good. Chloe, that's actually correct. But I'll bring it down. Give a few more seconds for you to think about it. Y, G, or both rows for this particular frequency over here. Let you all think about it. Okay, so think about it. Okay, when I look at less than or equals to 40, very good. Okay, I see some replies over here. When I look at less than or equals to 40, I need to look at the conditions for which it fulfills anything that's less than 40. In this case, this one, quite obvious, less than 40. But over here, do you all agree in this case, this is always less than 40 as well? So therefore, that is the notion of cumulating my frequency. What I'm doing in order to make sure it fulfills that particular condition over here, x less than or equals to 40, I am essentially adding this and this one over here. So yeah, so 5 and 10. So therefore, in this case, it's going to be 5 plus 10, which is 15. Now, henceforth, based on this notion over here, for, in this case, row x less than 45, does anybody want to tell me what the number is? What's the frequency? What's the value of C? Very good, Chloe. Any other answers I have? Okay. Anyone wants to give it a try? So in this case, cumulative frequency. Very good, Denise. Anybody else wants to try? I'll give you some time to think about it. Very good, Isabel. Okay, giving some nice responses over here. I'm liking the response over here. Okay, I'll give you a few more seconds for the rest to try. Think about it. Okay. Okay, so if you follow the notion, x less than or equals to 45, what are the conditions that fulfill it? I'm going to have this is less than or equals to 45. This is less than. This is also less than. So what I'm doing, I'm actually adding all of them up, which is 23. So therefore, this is how I fill in the values. We fill in every relevant value that corresponds. I think I might have drawn the arrow wrongly. Sorry for that. That corresponds to, sorry for that, to this particular alphabet over here. Okay, so a cumulative frequency, we are actually trying to see which row fulfills what is needed. In this case, usually summing up from top to bottom. Usually. All right. Now, you realize there is one particular value we haven't filled in yet, and that will be coming in the form of a bubble question. If you were to actually catch my answers very clearly, you will realize that A, this is actually quite straightforward. So from here, I'm going to launch the bubble. That's where it's only 30 seconds. Make sure your fingers don't slip. Launching the bubble in 3, 2, 1. Let's go. Very good. All right. Getting some good responses over here. For those who have yet to respond, you have 20 seconds left. Very nice. Okay. So we are looking to filling in this particular table with this bound. So how much is it? All right. Counting down. Last 5 more seconds. Last one. All right. Okay. Seems like most of you all get it, but I'll still go through because there is some discrepancy over here. So let's see how we fill this. Now, this is less than or equals to 50. So therefore, actually, all 4 of them fulfill this condition over here. So I have this one, this one, this one, and this one over here. Which if you were to sum them up, this is just saying that my value D is equals to 5 plus 10 plus 8 plus 7. Summing them up, this is going to give you a good value of 30. Henceforth, the answer in this case is number 2. All right, for those who just fill in number 1, you realize I'm talking about accumulating my frequency. Don't just copy this. And for those who have actually answered number 3, might have just sum only 2 of them. All right, so take note. I need to take note of all conditions. And this brings down to my point that the last frequency is always equals to my total frequency. Now, that is the reason why. All right, so I hope this is actually bringing down to a good note and understanding it clearly that this is my total frequency over here. Okay, so bringing down to a good start over here. Now, knowing how to fill my tables is one thing, but how do I fill in my graph? So, of course, first things first, if you want to fill in a graph, you need the data. So that's where you need to construct a cumulative frequency table. Once you have the cumulative frequency table, of course, this will be like your points. Okay, it's like a graph. So you need to plot them. And lastly, how you plot the graph? Essentially, drawing it with a smooth curve, not jagged points. And that's where your curve ruler may help you to actually sketch this curve. Now, how will they actually sketch the graph and what are certain questions that comes about? That's where we come to it. And I'm actually going to use the same cumulative frequency for the height of 30 plants. If we recap, step 1 is actually done. So if you look at the points over here, this is 5, this is 15, 45 is actually 23, and lastly, 50 is 30. So this is step 2, you plot it. Step 3, it is actually done. You just sketch the curve out. In this case, I don't want to hand sketch because this is very crucial in terms of how we read the graph. So therefore, I've drawn it for you. So this is essentially showing it from the previous bubble question and the work example 1. It's the same question, just that right now, we see what are the variety of questions that we have. Now, so over here, I'm looking for the number of plants that are shorter than 38 cm. Okay, 38 cm. But over here, let's think about it. Number of plants shorter than 38 cm, I need to know the value first. All right, I need to know the value for 38, what value it gives. Well, now here's the catch. For part A, because 38 is actually present over here and over here actually, in this case, this is correct. So 38, if you realize, I will actually sketch it from, maybe I'll ask you all, 38, do I sketch it in this case at the horizontal axis or the vertical axis over here? Where do I start from? In this case, if the name is too long, start from this axis, you write V. Start from this axis, you write X-axis. Very good, Denise. That's actually correct. We actually start from the X-axis. So in this case, for those who want to answer, this is actually H, this is actually V. Just give me your responses. Which one do I start off with? If it's X-axis, write H. If it's Y-axis, write V. I'll give you all some time to think about it. Okay, but Denise, good job over there because the units is given there. Very good, Chloe. All right, it's actually H over there. Anybody else wants to try? Where do I start? H or V? Okay, I'll give you some time, but I think most of you guys are getting it. Okay, so let me see the response. All right, perfect. So you realize over here, 38, and again to further 45, what Denise has actually said, because the unit cm is given, we start from 38. Take note, in this case, graphs, it's a little bit weird over here, so you actually have to plot the point properly. So in this case, my 38 is actually over here. Let me color code it in the same manner, so it's easier for you all to follow. 38. Okay, so we go from that point. So we go up, and we go here. So we find we go up, we go here. The value here will just be 11. So therefore, the number of plants that are shorter will just be 11 plants. Okay, 11 plants over here. Okay, it's just a matter of how we read it and where do we start from. Okay, now, is, it can look rather confusing. Next up, the percentages of plants followed by 43. Following the same notion here, you realize we just need to first look out for 43 over here. So 43 is going to be here, 41, 42, 43. So here, so 43 is going to look up over there. Okay, look up off the curve. And in this case, over here, 43. And it actually corresponds to, wait, let me see. Yeah, it actually corresponds to the value 20. But now take note, I'm looking for the percentages, or in this case, percentages of plants taller than 43. So what is my actual value? Is it actually 20? Or do I need to do something due to how I interpret this graph? Aha, take note. Some of you are actually falling into a trap. Chloe, the percentage is correct if I'm looking for shorter. That will be correct, Denise, as well, if I'm looking for shorter. I'm now looking for taller. Recall cumulative frequency. How do I read it? If I'm reading for 43 over there, this is actually corresponding to x less than or equals to 43. I'm now looking for more. Yes, that's correct, Chloe. Denise, you want to give it a try? Just change a little bit of the expression. That's right. So take note, if I'm looking for taller, we have to understand this is for shorter. So to change the orientation, I just need to taller. So I'm actually looking for this part over here. So therefore, I need to do a little extra thing. So it depends on the phrasing of the question, guys. It depends on the phrasing of the question. I actually need to do, okay, sorry for that. Let me just shift this up. I actually need to do 30 minus 20 over the total number of plants times the percentage. This will actually give me the correct percentage that is involved. All right, so just take note of the phrasing over there and everything will be smooth flowing. Okay, lastly, there is a particular particular restriction that can given. Just follow them. It's going to be, okay, let me see what color can I use over here. Okay, yes, last one. Taller than 39, shorter than 45. So therefore, taller than 39. You need to find 39. Sketch it out. Okay, taller than 39 over here. So this is going to give me 13. Shorter than 45. Okay, 45 in this case quite clear. But to show you the boundary, that's what I need to do. Now, guys, okay, just take note over here. Because I'm looking for taller than 39, shorter than 45. Hi, Shayna. All right, glad to hear from you. Taller than 45, shorter than 49. Yes, that's right. You actually have to give the answer of what Chloe does, which is 10. How do I get 10 plants? This one over here is actually shorter than 45. This one over here is actually shorter than 39. But I want taller than 39, but shorter than 45. So I'm actually looking at, in this case, the yellow color range over here. So that's where I finally do my subtraction because I'm looking for taller and shorter. So 23 minus 13, that's where Chloe gave me the answer of 10 plants. All right, so that's the different type of questions that can appear. Shorter than straightforward, but if it's taller, you might have to do a little something. And lastly, there's a boundary. Okay, and it depends on the interpretation of the question to how we understand, how do we do our cumulative frequency, and from our cumulative frequency, how do we actually understand the notation, how we understand the question based on the definition of cumulative frequency. So how do we, so based on the definition of cumulative frequency, how do we actually understand how to solve such questions? All right, all good? Okay. So if all this is clear, we are actually going to let you try certain questions. So a different context, couple question 2, 1 minute because it takes a bit of graph reading over here. So take some time, read it through. Okay. How do we solve this? All right. So take note, don't get tricked over here. Launching the bubble launcher in 3, 2, 1. Let's go. All right, perfect, awesome. Give it some try. Okay, very good. Okay, so I'm looking for the number of students who are doing, again, keyword 7 or less. So based on this, if you understand your cumulative frequency graph nicely, this shouldn't be a particular issue. All right, perfect, awesome, doing good. Okay, so 30 more seconds. I'm looking for 7 pull-ups or less. So which should I be reading from? Pull-ups or less. So where should I be reading from, guys? Where should I be reading from? All right, yep, that's right, Chloe. X-axis. So trace from there and see what you get. You have 10 seconds left. Find 7 in the x-axis and go from there. What should you have? Give me a very good hint ready. For those who have yet to answer, you have 5 more seconds. All right, okay. Seems like most of you got it. Perfect. Okay, now, as what Chloe suggested, we have to look from the x-axis, which is correct. So 5, 6, 7. We look here, 7. We go up. 7. Then realize, oh, it's actually just 10. So what's my answer? 10. 7 pull-ups or less, Denise. We are doing 7 pull-up. Just now we were saying CM, right? CM, so we look over here. But I'm looking for 7 pull-ups or less, number of students. Y-axis, it depends on the other phrasing. Based on this phrasing over here, 7 pull-ups or less. So, oh, okay, I'm looking for 7 pull-ups. So where is my pull-up axis? X-axis. So that's why we are looking for the x-axis over here. Does it make sense to you, Denise? Because we're looking for pull-ups here. Read the question. 7 pull-ups or less. So sometimes the units may not be so obvious as to CMs. It depends on the phrasing of the axis to how you trace it. All right, all good? Okay, if this is clear, you realize based on the phrasing of my cumulative frequency curve, if I'm number of students 7 pull-ups or less, I'm going to combine percentage now. Similar notion over here, but don't get tricked. Percentage of pull-ups who did more than 20 pull-ups. All right, launching the bubble launcher in 3, 2, 1. Let's go. It takes some time, read it through. You did more than 20 pull-ups. The keyword is more than. All right, perfect. Okay, seems like you guys are doing good. Looking at more than. Sorry for that. More than. Okay, seems like you guys are doing so well. All right, let's do this. Doing good, doing good. Counting down to my last 20 seconds. Okay, so right now, 20 pull-ups. Where do I look it from? Okay, some of you are falling into the trap. I see. Some of you are falling into the trap. Last 10 seconds. No worries. So don't worry, in the actual graph, that's where graph sketching can be a little bit iffy. So just be careful. In terms of graph sketching, I cannot emphasize this to what tips you have. Just be careful in terms of looking at the axis, how much is being divided, and henceforth the numbers. All right, so don't worry about it, Denise. That's where we catch up. Main thing is concepts-wise, we have to be clear. Now, more than 20 pull-ups. So again, pull-ups, we go on to the pull-up side. So that's where we have 20, and then we go up. Okay, then we go up to the 20. So we go up. Let me just draw the arrow. And then we move over here. So it's going to be here if I'm not wrong. Yes. 20 pull-ups. And then you realize it hits 36. Now, for those who gave me 90%, you realize you did for this side. But I want to look for more than. Remember, cumulative frequency tells me what? It's always the number here, it represents less than 20. But I want more. More means what? The other direction. Therefore, to find the percentage is going to be 40 minus 36 over the total number of students multiplied by 100%. That gives me 10%. And henceforth, my answer is number 3. All right, so for those who have answered number 2, which I only gladly see that there are only 2 possible answers. All right, 2 possible options over there. Okay, that's one thing. Good job for everyone, but just take note what happens of the errors. Why I say good job to everyone even though you answer wrongly for two? Because you're getting the right concept over there. Tracing is good. Just that one additional part. Take note of the subtraction. Okay, now you realize there's one more phasing of a question that we have. One more question before we move on to another new concept. Okay, we have less than, more than with the percentage. We're gonna have the next one. More than something, less than something. So really carefully, launching the bubble launcher in three, two, one. Let's go. All right, you have more than enough time for 1 minute. All right, and wow, okay, someone gave me the answer so quickly. Very nice. Okay, so look at the keywords again. More than 13, less than 23. More than 13, less than 23. What do we have? All right, so take note. More than 13, less than 23. What do we have? Okay, take note of how you read the axis. All right, just be careful. Okay, last 30 seconds for those who have yet to answer. Click on that button. Make sure you don't slip your fingers. Counting down to my last 10. Right? For those who have yet to answer, take note. More than 13, less than 23. All right, very good. Last two. All right. Okay, seems like most of you all got it, but there's a little confusion between two options over there. But no worries, let me go through. Again, more than 13 pull-ups. So I'm going to go to 13 again. 13 up, and that's where you realize I have 17 over here, up, and here, less than 23. That's where I'm going to have my 23 over here. Okay, and as such. And this is going to give me 39. Okay, now some of you have actually given me option number 3. I have a feeling so because this is 17 is for less than. Take note. When I do cumulative frequency graph, always remember this side is always less than 30. That's the notion of the value. But I want in between. More than 13, less than 23. So more than 13, less than 23 is the range. And if you were to look at it, this is what I'm looking for. Therefore, you actually need to do 39. Sorry. You need to do 39 minus 17. This is equal to 22 students. Henceforth, 2 is my answer. Alright, so these are the different kinds of questions whereby given a cumulative frequency curve and percentage, how do we actually find some questions? Alright, so I hope this gives you a better, clearer understanding of how your cumulative frequency curve comes about. Now, with this notion over here, if you realize when we did percentage, we are going to sort of link percentage to a new concept now we are going to learn, which is percentiles. Now, what is the notion of percentiles? If you picture percentile, what we are doing here, suppose you're the 90th percentile, say for example. Basically, you are scoring more than 90% of the students, if I were to use my example over here. So based on the students expect, I'm actually looking at the total frequency, total amount of students, and you score more than 90% of them. Okay? Based on this example, what we can do is you can picture the total frequency, total amount of students, and you can divide it into 100 equal parts. Each part we say it's a percentile. And how do we actually make use of this to solve percentile questions? So let's see, shall we? With a work example. Again, same example, same curve. So how do we use a graph to find a certain percentile? Now, 70 percentile over here means my graph over here is equally split into 70 equal parts from the bottom, right? 70 equal parts of my total frequency. So out of 30 plants over here, what is the 70 percentile? Because, or what is that particular number such that it is sort of taller than most of the other plants over here, based on this context. Okay, so how we calculate the percentile, in this case, is for the frequency. So if your picture is going to be 70 over 100 times the total number of plants, all right, which is 30. Okay, it's not 3 over 7, Chloe, because we are taking 70% of the total frequency. Okay, this gives me 21. Yep, that's right, Chloe. That's very nice. Perfect over there. Again, 730, which is going to be my total. Good job here, Chloe. Now, how do we find the percentile? That's where Denise mentioned. When do we, or in fact, a follow-up question from what Denise has mentioned. When do we sketch on the y-axis? Because now we are searching for the percentile. So basically, we are trying to find out, okay, 21 plants is the 70th percentile. But what does it mean? That means how many, or what is the boundary such that it is shorter than that particular number. So maybe if I sketch it out, it's a bit easier. So 21, if I were to actually just draw it out. So 21 over here, if I were to draw it down, in this case over here, so you realize it's in between 43.5 because halfway mark, each interval is 1. So if I divide by half, it's 43.5. So what does it mean? Okay? This means that if I look at my 70 percentile and I realize, oh, 21 plants, what does it mean? This means that 21 plants have height that's actually less than or equals to 43.5 cm. So that means I have 70% of the plants that is less than this particular height. What is this percentile? How do we find it? We realize, oh, 21 plants, that is the 70 percentile, are less than a certain height. But what is the height? That's why we trace it here, and now we realize, oh, that is actually my 43.5 cm. That is the percentile. Alright, so I hope this is a little clear in terms of looking for percentile based on the total frequency. We are looking at how many plants in this context are lesser or shorter than a particular boundary. What is that boundary? Trace it on the y-axis. Alright, so with this notion over here, I hope this is clear because that's where we are going to go and test your understanding on again the next of a question. So what we are doing, same graph, you realize the questions are a little bit similar, but I want you to see how one question we can face so many types. Okay, 20th percentile, how do we find it? Launching the bubble in 3, 2, 1, let's go. Very nice. Let's give it a try. Some of you are falling into the trap that I'm setting over here. But nevertheless, let's give it a shot. 20th percentile. So what is the percentage I am looking for? Very nice. Seems like you guys are getting it. Very, very nice. Oh, no worries, Shayna. What did you forgot? I think you forgot to trace, right? That's the common error that we make over here. Yeah, that's right, Chloe. But you need to do something to the number. Last 10 seconds. Yes, you got 8. But what do you do with the 8? You need to do something. That's right. Okay, so I think you know where is that particular error. So yes, I get what you mean, Sheena. Don't worry, don't worry. I get what you mean. So don't worry about it. Okay, time's up. Okay, most of you all got it. Yes. So what Chloe mentioned. Firstly, when you find the 20th percentile, we need to go from 20 over 100 times the total frequency. In this case, 40 students. This is equals to 8. Now, 8 over here is the number of students, and in this case, basically 20% of it. But what we need to do, don't worry, Sheena, don't be shocked, okay, is from 8, what is the boundary that sets it? So we need to trace it down. So that's where most of you actually answer 8 for me. 8 is not correct because you actually have to trace, which then gives me 6 pull-ups, and that's why that's the answer. Okay, so just take note over there, and that gives me the answer. Now, why is it not 20 over 40? Take note. 20 pull-ups doesn't mean it's the 20th percentile. 20 in this case is not the 20th percentile. If I look at the percentile, I'm looking at based on the total number of students. How many percent of it is considered 20%? I'm looking for 20%, not 20 over 40. I'm looking for 20% of the cumulative total frequency over here. That's the notion of percentile. Right? Do you understand me, Denise? That's right. Okay. Again, 40 is the frequency. Percentile, the notion percent. I'm looking for 20% of the total frequency. So that's why I cannot do 20 over 40. All right, but these are good questions I'm facing over here. Very good, very good. So keep up the questions so that I can actually answer them so everyone here can benefit. All right. Now, percentiles over here, you realize it goes to percentage. But let's see certain questions over here whereby it has a certain way of calculating our percentiles. What do I mean? So you have to recall, we have our few things that we can calculate, which is first one, the median. So what is defined as the median? So median over here, we can actually visualize as the value in the middle position. So the middle position over here. So now, if I was to talk about middle position, very good, Shayna, that's the answer. But in this case, what percentile I'm looking for? Okay, infraction-wise is correct, what I'm looking for. Very good, Chloe. Okay, what percentile I'm looking for? Very good, Denise. I'm looking for the answer. Very good, Shayna. I almost gave the answer. Okay, because I want everybody to try. Now, give it a shot. What is that number I'm looking for? Okay, let me wait for some response. Give it a few more seconds for everybody to think about it. What is the number I'm looking for? If it's in the middle. Very good, Jerome. That's actually correct. Very good. Okay, so if you are looking for it, okay, the magic number in the middle, 100%, the middle, it's actually 50%, so 50th percent. So how do I find the median? Essentially, just now when you do the tracing, you trace from the axis of the cumulative frequency, right? So, do this. Okay, what we do, because it's the 50th percentile, we do 50 over 100 times the total frequency. We trace it at the cumulative frequency axis, which is, if you recall, it is usually at the y-axis. Usually, because sometimes certain questions may come in at the x, but just take note, we trace it at the cumulative frequency axis, which is my y-axis. Usually. Okay, so that is the notion for median. Now, two more interesting concepts that we can talk about. Lower quartile. So when we talk about the lower quartile, you can picture, I'm looking at the lower quarter of the graph. If you picture quarter, it feels like a certain number. But what happens in this case? Lower quartile in words, I can say it's the middle value, but take note, don't worry, it's the middle value of the lower half. Correct, Shayna, and that's correct too, Chloe. But let me bring this question to everyone, so Chloe, take the surprise to yourself. What is that percentile number I'm looking for? What is that number? What's that magic number, guys? Okay, Chloe's giving me. It's not, okay, yes, okay, typo. Yeah, that's correct, Denise. All right, anybody else wants to try? What is that number I'm looking for? I'll give it a while for everyone to give it a try. Okay, so if you picture, very good, Shayna. Perfect over here. Very good, Isabel. Perfect. Very good, Jerome. Wow, you guys are giving perfect responses over here. Anybody else wants to try? All right, very nice, very nice. Perfect, perfect. Awesome job you guys are giving. So realize what happens is it's actually the 25th percentile. And how do we sketch the 25th percentile? If you would see the relevance from this particular sentence, essentially we are going to the same notion over here. Trace from 25 of the total frequency. So 25, we look at 25%. 25 of 100 of the total frequency, again from where? Cumulative frequency axis. Okay, so once we have this notion, we realize, okay, if you have the lower quartile, do we have something called the upper quartile? Fortunately, yes. And that's where we all sort of correspond over here. Again, upper quartile is going to be a quarter, and from the top. So if we were to just translate it, it's going to be the middle value from the upper half. So what is the percentile? Very good, Shayna. That's right. Very good, Chloe. That's right. You guys are very active today. I'm liking it. Okay, keep up this activeness so that everyone can share. Very good, Isia, correct? Yeah, very good, Isa. Very good, Isa. Right, correct. Very good, Jerome. All right, give me the answers more. Anybody else wants to try? Give it a shot. Try your answers. If it's not correct, it's fine. Don't worry. That's where we all learn. All right, perfect over here. Anybody else wants to try? I'll give it a few seconds. Very good, Denise. I'll just wait a little while more. Okay, yes. So I think if you have gotten it, it's the upper half. So we're actually looking at the 75th percentile. And how do we do it? If you look at the median way, the lower quartile way, the only difference is just none other than changing the number to 75. 75 over 100 of the total frequency and the cumulative frequency axis. Alright, so that's the notion over here, and this is to summarize what is median, lower quartile, and upper quartile over here, and how do we actually sketch it. And now from there, there's actually two things that we can actually do in order to sort of calculate based on the values we have. So let's say if I have my median, lower quartile, and upper quartile, what can we calculate? So there are two things that we can actually calculate. One is what we call the IQR, in this case, the interquartile range. So let me write it out in case some of you wonder what is IQR. IQR is what we call the interquartile range. In this case, if you were to recall, upper quartile is actually what we have as the 75th percentile. Lower quartile is what we have as the 25th percentile. So basically, we are looking at the range of values between the 25th percentile to the 75th percentile. So upper quartile minus lower quartile. And henceforth, you realize IQR is a bit small. Range is a bit bigger because the highest value can be higher than the upper quartile. Sorry for that. Higher than the higher upper quartile. My lowest value can be lower than the lower quartile. So that's where the range comes in. It's just depending on which is the highest value, which is the lowest value, you take the subtraction. Alright, so this, if you think about it, this particular section is actually just build up from the percentiles they have been doing. Alright, so what do I mean? Okay, now let's go on to a work example, in this case following up from the bubble question. Now, using the graph to find the median. So first things first, median is my 50 percentile. So now from the 50th percentile, what do we do? Again, we do 50% of the total frequency. 50% of the total frequency. So it's going to be 50 over 100 times my total frequency. This is going to give me 20. Now, 20, where do we sketch it from? Yeah, that's right, Isya. That's perfect. That's absolutely correct. And in this case, we know the median is not 50, Chloe, take note, but it's the 50 percentile. That if you are typing it correctly. And percentile is sort of, you can talk about it, the percent, it's not really exactly percentage, but you can link it in that manner. Yeah, you can link it in that manner because percentile, I'm looking at 50% of the values that are less than or equal to that part. So in a way, yes, you can say percentile is sort of like percentage. Alright, I hope this gives a reply. I cannot say it's exactly because it's not really exactly percentage, but the concept links with percentage. Okay, so what do I mean? In this case, from 20 is the value for which it is half of the total frequency. But what I'm doing, I need to find the median. In this case, if we go it down, median is 15. Therefore, median over here is exactly 15. Alright, I hope this kind of makes sense. And to bring it down, so it is sort of like percentage. It's not exactly, but the way we do it is similar to how we calculate percentage. Okay, so maybe to clarify with Chloe, I think you meant the median is 50 percentile, so we need to do 50 over 100 times 40%. And yeah, okay, let me just analyze your questions first. Yes, correct. 20 is the 50th position in the total frequency. Yeah, it's not really percentage, that's right. Yeah, but the way we calculate it is like percentage, as we mentioned before. Percentile is like cutting my graph into 100 parts. So 20 is actually the 50th position. Yeah, that's right. You can think about it that way. Okay, yeah, you guys are getting it. Nice response from you, Chloe and Denise. So from here, now we have done with now that I have done the median for you all, let's try and see whether you're able to apply the rest of the questions. So next up, same question, lower quota. Let's see how we do it. All right. Launching the bubble launcher in three, two, one. Let's go. Right, very good. Just remember, if you follow the way and understand why the method is as such, these few questions will be quite smooth flowing for everyone. All right, very good. I'm liking the response here. Okay, take note of the errors that can happen. Okay, and the magic keyword. Okay, 25th percentile to 25 doesn't mean the pull ups as well. There's a lot of hints over here. Let's see the response. All right, very good. Perfect, perfect. Okay, 15 more seconds. Waiting a little more. Very good. Perfect. Keep up the response. I'm liking the response here. Counting down. Last 5 seconds. Awesome job down here. Very good. Let me see. Okay, there's a little misconception. Some of you all forget to trace. What do I mean? Lower quartile. Take note. Lower quartile is going to be at my 25th percentile. So some of y'all, when you calculate the 25th percentile, you are going to give me 25 over 100 times 4. Then you'll get me 10. They realize, aha, very nice. I click option 2. They were like, why is it wrong? Because 10, it's the value, or in this case, according to Denise, I will use the definition, which is easier. It's the 25th position. But what is that value that gives me the 25th position? This is where I trace 10 down. And you realize this value then gives me 7. That's why my answer over here is 4. Okay, so just take note, remember to trace. If you forget to trace, that's gonna be gonna give you an incorrect. So always remember to trace over here. Okay. Now, next bubble question, lower quota. Let's not repeat this mistake. Remember to trace, guys. Remember to trace upper quota. Launching the bubble launcher in 3, 2, 1. Let's go. Alright, perfect. Just remember the word, the magic word. Once you get once you get the number, remember to trace, trace, trace. Right? Remember the magic word trace. Upper quarter, how many percent? Yes, let me give you a hint. 25, not 25, sorry, 75. Okay, but you must remember it's always 75. This time over here, I will give you the notion. Next time, just take note. You will not be given. But over here, because it's the first time you're learning, I'll write down it's the 75th percentile. How do I do it? Alright, since I'm getting there, okay, very nice. Notion, 20 seconds left. Okay, okay, counting down. The last 5, 3, 2, 1. Okay, lesser errors on the tracing, I would say, or actually the same. Okay, so take note. Remember to trace. Why do I say that? How do I know you all are not tracing? Because when you calculate 75 over 100 times 40, this gives me 30. But some of you still give me option number 1 because when you trace, 30 is actually the position over here, the 75th position. So you need to tell me what is the value that corresponds to the 75th position, which then gives me my answer over here if I were to scroll down all the way at 18. So that's why 18 is my answer over here. Alright, so before I go on to the next bubble question, alright, just to let you all have a heads up, that it is essential for you all to know the positions of your lower quartile and my upper quartile. Okay, median, I think quite straightforward. Okay, median is 50%, but in this case, lower quartile is my 25th percent. And I give you a hint, please take note of this value. You require it for next bubble question. Upper quartile, 75th percent. So try to get this quartile. So remember lower quartile, lower quarter. So lower 75%. Okay, lower 25%. So 25th percentile. Upper quarter, I'm looking at the upper 25%. So I'm looking at the 75th percentile at the bottom. And take note of this value as well. Alright? Why do I say take note of these values? Because the next question, interquartile range. How do you calculate the interquartile range? Alright, guys, let's see whether you got it. Launching the bubble launcher in 3, 2, 1. Let's go. What is my interquartile range? Very good. Alright, take note of these values. Your interquartile range should be over there. Okay, so let me give you a hint. If you forget the values, it's still possible to calculate. Just that it's gonna be a bit longer. Right, so I can't really switch back and forth. Over here, maybe I can do. Okay, so I'm going to give you all 5 seconds. Okay, I'm just switching a little bit. Don't worry. This is my upper quartile. This is my lower quartile. What is my interquartile range? All right, 10 more seconds for those of you to answer. Quickly click the option. 10 more seconds. What is IQR? How do I calculate my IQR? 2 more seconds. Okay, seems like not everyone answer, but most of you got the options right. That's good. IQR, if you recall, IQR is actually upper quartile minus lower quartile. So over here, you realize this is actually equals to 18 minus 7. We essentially, if you take a look, it's just option 1 and 2. Subtract them, you get 11. That's where I get that. Okay, so right now, I believe upper quartile, so that's why how the values are all linked, and I hope you're getting it. One last question before we call it day today. Because with interquartile range, we have also this thing called the range. Range in this case, you don't need to know what is the value. In this case, what is the definition of range? What are the range of values? How do I find it? Based on this graph. Yeah, I'll let you think about it. This is going to be 1 minute long. Launching the bubble in 3, 2, 1. Let's go. Very nice. Perfect. Click on the responses. All good. Okay, so what is my range over here? How do I calculate range? Okay, I have the responses. It's going good so far. It's going good so far. All is good. Okay. Take note that is not my range. Shina, that's not my range. What is the highest value? When I'm looking at the value, do I look at the cumulative frequency or the value of the pull-ups? Yeah, that's right, Shana. It's not the highest number in the 70th percentile. It's literally the highest number. It's just the highest number. Or you can think about it that way, but I don't know whether I'm interpreting correctly. Okay, so for range, right, no need to think so. No need to be thinking so hard. It's literally the highest values of all the pull-ups minus the lowest value of all the pull-ups. All right, I'm glad you're getting it, Shana. So from here, what's the highest value? You realize the highest value I can get is at 40, which is the total frequency here, and it corresponds to 25. What is the lowest value? Lowest value is literally at the frequency at the bottom, which is 0. Now, I think, Chloe, I get what you mean, but this is actually not the actual definition. It's literally just the highest number of all the numbers, of highest value of all the numbers here, minus the lowest value, which in this case is 25 minus 0, which is 25. Okay, and this gives me the answer for 4. Alright, okay, I hope you guys are getting it. Okay, just over here. Take note, range. When I talk about the range, am I talking about the range of the total number of students or the range of the values I'm looking for? So yes, I have 40 students in this case. But what is the values that it takes for these 40 students? Ah, when I talk about the range, take note, range is always the values of what Chloe mentioned over here. The pull ups, I'm looking for the range of the values for given the total frequency over here, what is the range of values for which it take, which it can take. That is the definition of range over here. I hope this is clear, Denise. And thank you for helping me over here, Chloe. Yep, that's right. Okay, now there's one last thing over here, just nice. I don't need the whole 4 minutes before I end the class. You realize highest value is always here, lowest value is here. But is it necessarily that my lowest value is 0? It's not always this case, because if I were to bring you to one work example, give me a moment, let me find my work example. If I were to look at my work example, say, okay, let me use a cleaner graph. Say over, wrong graph, sorry. I guess I have to use that one. Sorry, give me a moment. Yes, over here. If you look at this one, can anybody tell me what will be the range for this question? Think about it, what's the range of this question? Highest value minus lowest value. Very good, Jerome, that's the answer. Very good. Sorry if I pronounce it wrongly. I hope I didn't really pronounce it too wrongly. But very good, Isa. Anybody else wants to try? Follow the definition. Highest value is going to be, given the total frequency, what is the highest value? In this case is 50. Lowest value at 0, what does it give? 30. So that's why in this case my range, okay, it's not part of this question, but I just want to go through because I want to tell you all the lowest value may not necessarily be 0. Henceforth the range here for this particular question. Oh, okay, got it. Got it, Iza. Now it's better. Okay, I hope this pronunciation is better. All right. Okay, got it. All right. Thank you for the analogy. Now I can pronounce the name better. But for the rest, everyone, do you understand how this range comes about? Okay. So that's why in this case, if you have further queries with regards to range or other things, there's a Q&A session. But that's actually it for today. All right. So in order to fortify this question, there's a try it yourself in Genie Ask. You can try the questions. Okay. So there are actually a few parts. Part A, this is worth 20 bubbles. Just fill in the frequency table. Part B, use the graph to find the things that I've learned. Median, lower quartile, upper quartile, interquartile range, 70th percentile. Oh, now ask the complete range. Okay. Nevertheless, it's okay. Lastly, a little bit of an interesting question over here that I'll specify certain rules. You realize I didn't really sort of go through this question in class, but it is doable. It is doable. Okay? This is actually just a variation of percentile question. Okay, whereby if I talk about, yeah, I'll give you all some hints over here for those who are here. So this is a variation of percentile questions, whereby if I talk about if 45% of the student pass, what does it mean? Okay? Let me give you a hint over here for those who want to attempt the try yourself. This means that if 45% of the students pass, more than 55, it's not a 45 percentile, Denise. 45 of the students pass. How many percent of the class pass? It's actually 55% of the class that pass. So what is the percentile I'm looking for? So again, Denise, that's why you fall into the trap. I'm looking for 45% of the students pass. Based on the definition of cumulative frequency, what am I looking for? I'm looking for how many students pass. This is saying that more than 45% of the students score a particular mark. for a particular mark. So if more than 45% students score a particular mark, that means more than something. Again, that's not how cumulative frequency is given. I'm actually looking for less than something. So how do I flip this percentage over here? Okay, so I hope this hint allows you to grab those bubbles. And a tip for today, because when we look at graphs, okay, it's going to be very confusing. And understand, yes, a ruler doesn't work here, but what you can do, if you use a ruler to mark out the key values, the percentiles, median, lower quartile, upper quartile, it will help to prevent careless mistakes, sorry for the typo, careless mistakes, and ease up your checking process. Alright, so that's it for me today. So what have we learned? The introduction to cumulative frequencies, how we calculate percentiles, and how percentile links to all these things. All right, so that's it for me today. If you have any questions, there's a Q&A section. I'll stay for a little bit more to answer any of your queries. But otherwise, this is teacher Jason signing off, and I hope this is clear. So I'll see you all in 2 weeks' time. Because next week is Chinese New Year Eve. Bye bye, Denise. Next week is Chinese New Year's Eve. There's no lesson on that time slot, so enjoy